Welcome back to Machine Learning Guide. I'm your host, Tyler Ranelli. MLG teaches the fundamentals of machine learning and artificial intelligence. It covers intuition, models, math, languages, frameworks, and more. Where your other machine learning resources provide the trees, I provide the forest. Visual is the best primary learning modality, but audio is a great supplement during exercise, commute, and chores. Consider MLG your syllabus with highly curated resources for each episode's details at ocdevel.com/MLG. I'm also starting a new podcast which could use your support. It's called Lefnir's Life Hacks and teaches productivity-focused tips and tricks, some which could prove beneficial in your machine learning education journey. Find that at ocdevel.com/LLH. Welcome back to Machine Learning Applied. In this episode, I'm going to be interviewing coworkers from Dept. Matt is an expert in architecture, and Jirwat is an expert in DevOps, or developer operations. These two skills combine in the deploying of a full-fledged product that can be used by consumers, a web app, a mobile app. Most of what we've talked about in this podcast series is machine learning, how to develop and train your model inside of a Docker container, or even developing and training your models on the cloud by way of AWS SageMaker's Studio notebooks. Now, our skill sets are on the machine learning side, but eventually you want to get that model into the hands of a customer. After you have trained your model, whether on localhost or on SageMaker, you will deploy your model through SageMaker to a SageMaker REST endpoint or to a model registry that can be called as SageMaker Batch Transform Jobs or SageMaker Serverless Inference Jobs. So now you have your deployed machine learning model ready to be used, but who's going to use it? That's where all the stuff from this episode comes in. Now, I know I have talked about a lot of the tooling and concepts from this episode in the past. And I promise I'm not going to turn this podcast series into a full stack /architecture/DevOps podcast. And that's actually why I'm creating this episode. I wanted to talk to my colleagues who are experts in the field, stop bumbling my way through these episodes and wasting your guys' time, and just say, hey, Matt and Jirwat, let's nail a coffin. How do you do this as a machine learning engineer? How do you productize and deploy your machine learning model as a full product in the cloud? Should you do that? Now, to get you thinking along that track, I want to talk about my journey with Nothi. Nothi was inspired by the publication and accessibility of these Transformers NLP models. The Hugging Face repository had all these models, summarization, question answering, and I thought, these would be really great for use in a journal app to give people recommendations and resources. Let me see what I could pull up. Crack my knuckles, and I get typing away. I deployed these models previously as Docker containers running on AWS Batch. Now I'm moving everything over to AWS SageMaker. On SageMaker, you can deploy models that you train, or you can deploy pre-trained models as REST endpoints or for use in serverless inference jobs. Great. Now that I had a machine learning model, I had to figure out how to get that to users so that they could start journaling. Well, the next step was to deploy a server using Python and FastAPI to AWS ECS, or Elastic Container Services. And a wrapper on ECS that makes it easier to work with is called Fargate. Fargate will manage the scaling up and down of your Docker-based servers based on load on the servers. Great, now I have a server, but I need a database. So I created a AWS RDS, or Relational Database Services, Postgres database, and I had to create an IAM role, attach that to my Fargate container so that it has access to my RDS database. Then I had to make Fargate accessible from some other service, namely the front end, which we'll talk about in a bit. So I spun up an application load balancer, ALB, that has an IP address. The IP address is registered as a domain name on Route 53 in AWS. Tie that ALB to my Fargate service. Now the whole thing is accessible by an IP address. Finally, I needed a front end so that the users could write their journal entries and communicate with the server. And the server is going to kick off the SageMaker model inference jobs. So that front end was written in React, that is JavaScript, HTML, and CSS. And then I dropped the build artifacts of that React codebase into an S3 bucket. S3 is AWS's service for storing files. Within S3, you can checkbox make this bucket publicly accessible as a website. Now, if you want your S3 bucket to be a public website, the buck doesn't stop there. You actually have to do another step, and that is to put what's called CloudFront distribution over your bucket. That CloudFront distribution's goal is to cache those files at various locations around the world so that it's more fastly accessible by users in various locations. That's CloudFront's purpose, but it's actually a required step if you want to add a domain name, again, through Route 53. So I register a domain name, nothi.ai, it's a record to that CloudFront distribution. The CloudFront distribution points to the S3 bucket. The S3 bucket's files are React, JavaScript, CSS, HTML that are making API calls to my Fargate container through the application load balancer. The Fargate container is sitting on top of ECS, which is managing the scaling up and down of that service. The Fargate container has attached to it an IAM policy that gives it access to the database on RDS. And the Fargate container will make calls to the SageMaker model endpoint in order to run inference jobs using machine learning. Oh, and did I mention, you don't want to string all this stuff up yourself by pointing and clicking your way through AWS console. The reason for that is it's hard to track changes of your architecture over time, or to know what services you have running and which ones are affiliated with each other. Or let's say you make a change and you want to keep track of that change. Well, you won't be able to keep track of that change unless all that stuff is stored in code. And so there's a project I'm using called Terraform. Terraform is what's called infrastructure as code. It lets you manage all of the deploying of your cloud services in a code file. You can then check in that file to GitHub, and then you can use that file to track changes to your architecture over time, or so that other users can repeat that architecture on their end, or so that you can make subtle changes in, let's say, your prod, dev, and staging environments just by way of code. So I just mentioned a slew of cloud hosting services on AWS and how you would do that in code. And is your head spinning? Because mine is. And so that was the impetus for this episode, was that the last year's worth of bumbling my way through architecture and DevOps, when my specialty is machine learning and data science, as I'm sure is the case for most of my listeners, I wanted to get some experts on the line and say, what are the popular tools out there and which tools should be being used? Are all of these skills valuable to a machine learning engineer or expected of a machine learning engineer in the job market? Should we be bothering with this stuff, or is it too big a pill to swallow and we should be leaning instead on our DevOps colleague or hiring somebody to do this for us? And so that's the kicking off point for this episode. I hope you enjoy. Welcome back to the show. Today, we're going to take a diversion and we're going to talk about DevOps, or developer operations, and architecture. And we have on the show two coworkers from Dept, Matt Merrill. Go ahead and introduce yourself.
Hey, I'm Matt Merrill. I'm a director of engineering at Dept US. I come from a background of Java development and Node.js development. I've dabbled in DevOps. It's something that I love. I'm usually the guy on the app team who is reaching across the aisle to the ops folks and things like that. I've been doing this for over 15 years and I'm happy to be here.
Hi, my name is Chirwat Bhutia. I am the DevOps practice lead at Dept. I started out my career as a Java, Perl, Python programmer, and I was doing DevOps before the term DevOps came out. Because of my varied interests, I would always talk to the ops because I like Unix administration. I would always do the CI/CD, the Jenkins, because no one in dev wanted to do it. I would always maintain the dev servers again because no one wanted to do it. And I started doing automation of our application because I didn't want to do it by hand. And I learned that, wow, Terraform, Ansible, I love this. So I pivoted my career from Java development to DevOps.
So For my listeners, I promise I'm not going to turn the show into a DevOps/architecture show or full stack. I've been taking kind of a direction with that in the last few episodes. I talked about SageMaker, AWS, but this might be the last episode where I talk about DevOps. I've kind of been bumbling my way through DevOps and how it relates to machine learning for anybody in machine learning who actually wants to deploy their models to the cloud for a client where they want to get their model online. But in this episode, we're going to kind of try to really dial down DevOps, the tools you'd use. What is it? How does it play into the machine learning ecosystem? Whether you've been developing models on SageMaker or localhost, and now you want to get that thing online. So we're going to talk to the experts here. Jirwat's going to take us through DevOps. Matt's going to talk about architecture, and we're going to see how does that fit into the picture from a machine learning perspective. So Jirwat, what is DevOps?
So it is a philosophy and a tools so that the dev and the ops can work together to help deploy code and applications safer, quicker into production. So it may be good to highlight some of the problems that DevOps is trying to solve. Originally, and still happens today, the devs and the ops, even though they both work in technology and they both work in the same company, they don't talk to each other. It's siloed. And we see that numerous times, even now when dev does an engagement. So DevOps is a way to have the common tools and common communication and process. So that way these two silos can work together well. And as we go on as a podcast, we could talk about some specific tools and some specific processes that makes DevOps work.
Yeah. So a lot of my listeners, or at least I know a lot of machine learning coworkers or colleagues in the past, what they end up doing is either they write a model on localhost. They're using TensorFlow or Keras or PyTorch, scikit-learn. Ideally, often they'll be using a Docker container. So if they're on a Mac, they'll have a Docker container that runs machine learning. They're not going to be able to use a GPU because of the max limitations. If they're using Windows, they might be passing through to WSL2 by way of Docker and writing machine learning models. They might be using a Docker container that inherits from NVIDIA containers or Hugging Face containers. More often the case, what I see is people are writing their models on Jupyter notebooks in the cloud. So they'll create a GCP or an AWS account, and they'll go to the machine learning toolkit. So in AWS, it's called SageMaker. They open up SageMaker. It creates for them a Jupyter notebook right off the bat. They open up that notebook and they start typing Python code. They write a model. They're using Keras. They train it. And when they deploy it, SageMaker has all this tooling for deploying a model. You just say model.deploy, and it will do all the stuff for you in the background. It will spin up, who knows, EC2 instances, ESS instances. We don't know exactly. Sometimes using Docker, if you're inheriting from a SageMaker Docker container. Sometimes it does all the containerization for you itself. And all you do is write some Python code. They call that bring your own script. But what happens is machine learning engineers, they know Jupyter, they write some Python, they deploy a model, and then the rest, it's like, where do we go from here? How do we make that available to the internet, to our client? And that's kind of where we stop in the podcast and you begin as somebody as an expert in the orchestration land.
Yeah, so that's a great question because I actually experienced this firsthand. So when I was working with Cambridge Mobile Telematics, CMT, the dev machine learning team, they were playing around with SageMaker in the sandbox in the dev environment. And what became a experiment became really popular to analyze data, process data, display data. So one day they came to me and say, hey, we got this dev SageMaker in dev and we want to deploy to production. And I didn't know anything about SageMaker. I barely knew anything about Jupyter notebooks. The only thing I knew was cool UI for Python. That's basically all I knew about it. So, one of the DevOps philosophy is collaboration, right? The devs and the ops working together to achieve a common goal and deploy it. So it was a two-way street. So they taught me about Jupyter notebooks, SageMaker, things like that. And on my end, I took a look at their dev implementation and I saw a lot of things that had to be modified before we could deploy to production, which is fine, right? This topic is so complex that we're not expecting machine learning devs to understand it. So to just give some examples, I had to encrypt the disk because it had user data in it. There was hard-coded database, usually passwords on there. So we had to use this thing called IAM, execution roles, to secure and, get access to the database, secrets manager to retrieve the secure username password, and to make backups in case things crash. So things like that, things that you have to do before you go to production. And that's why you want to work with your DevOps team to do that. We're not expecting the devs to think about all the stuff that has to go before going to production.
Actually, now that you mentioned, so you talked about IAM, you talked about secrets manager. Actually, what is architecture? And Matt can chime in on this. What is architecture and how is that different from DevOps? I imagine there's a lot of crossover. So Matt deals primarily in architecture, Jirwat deals primarily in DevOps. In what ways are those roles similar or different? Where does one begin and the other end?
Yeah, that's an interesting question. I've actually never heard DevOps and architecture compared like that. But let's start with what I think architecture is. And I'll step back by saying there's this perception, I think, in software engineering that an architect is kind of like some kind of, and I mean this tongue in cheek, like godlike figure who sits on an ivory tower and sends down edicts for how a team needs to implement something. And there certainly are those type of architects, but I think that that's probably the worst type of technical architect you could possibly have. I see architecture as systems engineering, how different systems interact with each other, and how can you make a healthy whole system that is as simple as you possibly can make it. Maybe each individual piece is complicated within itself, but how are you going to make all of those different things in your business talk to each other? Whether it be the customer relationship management system feeding data into your machine learning model or whatever it might be, how are those things going to play nicely together? How are you going to make sure that there are teams of people with the right skill sets to support those things? Thinking that far ahead, thinking about how these applications are going to get deployed and making sure that you do have a DevOps team or a cloud engineering team or whatever you want to call it that can support that type of stuff. I always like to think of it as a cross-cutting technical person who is at the service of different teams who can help kind of roadmap these things. I really like the discussion that you and Jirwat were having, that Jirwat mentioned about we can't expect machine learning engineers to know all this stuff. We can't. Right. It's unfair. It's its own topic. It's spot on. You need at least one person, if not more people, to do these type of things. And I like to think that the role of architecture is kind of the person who can take a step back, or people that can take a step back and think about how all this blends together before it goes out to users. And I would say that most small companies, you wouldn't start with an architect, but once you start getting bigger, that's when you need to start thinking about having somebody in that role. And ideally you have somebody grow into that role organically who has all the context and history and things like that.
Probably commonly comes from maybe full stack, knows how the server ties to the database, ties to the front end, how to get a mobile. Okay, that makes sense to me. So am I right to say that an architect blueprints the whole thing and then a DevOps makes it happen, at least in the cloud? And that's where my confusion was, as I thought of those two roles as similar in the way that a DevOps would string these services together, actually in implementation.
So I think it just depends on the architect and their expertise. So I've dealt with numerous different architects for numerous different clients and companies. Some architects are very high level, right? They'll draw a diagram and say, oh, okay, we have a container. These are the requirements. We needed 5 nines uptime. We need a cluster. We need to handle this load, this security. Here's the diagram. DevOps, you figure out the implementation to make it work. Other architects, especially folks who are promoted from the trenches, oh, okay, well, I want all this, and this is how I want it, right? I want, Fargate, and I want Kubernetes or whatever tools that they like. Here's the recipe. You just follow it. So it just depends on the architect and their skill sets and their personalities.
I like to think that the more effective architects are somebody who knows when to do each of those things at the right time. You don't always want the blueprint because you might have an effective team. I like to think it's as much, art as science and also just human interaction as technical work.
Sounds like the conclusion then is that taking on DevOps as a role, as a machine learning engineer, is too big of a pill to swallow. If you're going to one-man band a project as a machine learning engineer, maybe for a client, let's say it's one machine learning engineer who just landed a client who may or may not have other people working on the project. Taking on a bunch of DevOps technical know-how would be a lot to ask, because in a way it's a role in its own right. It's not just a suite of skills that's valuable for any technical person to have under their belt. So Jirwat, that being said, can you speak to sort of the level of complexity involved in doing DevOps and why maybe a machine learning engineer wouldn't want to take on all this burden themselves?
Right. So especially security is the one that's scariest, right? Especially with machine learning, you're probably going to be touching sensitive data, analyzing sensitive data. So if this data is exposed, well, it's bad times for you, bad times for your client, the company you're working for. So at that point, you probably want to hire a professional to take a look at your implementation. And, here at Dept, we specialize in that to make sure that the application that you wrote on your laptop can be deployed quickly, safely, repeatably to production. And security is probably the most important thing. We've done that with plenty of clients and it's not just the application that needs to be secured, it's the actual entire infrastructure too, right? There's the network. We see plenty of times where the network is public IP, wide open to the world, easily hackable. There's these things called S3 buckets where you usually store your data. That's open. So security is the one thing where it pays to have a professional come in and take a look and tie it down.
Cool. Jirwat, I'm curious what you think of this, but I would say everything you said is spot on. Like, that is not something I would ever advise an ML engineer to try to dive into half-heartedly. But I think that there are certain things that an ML engineer can do and certain skill sets that they can start to brush up on that will position an ML project well to be taken over by a DevOps team. And I think we're probably going to talk about some of those. So I'm curious if that rings true with you as well. Since I'm not a DevOps expert, I just it's on my periphery.
So usually what I've seen is Terraform is pretty easy to pick up, right? So whether it's ML or a dev that says, okay, hey, look, I wrote this Terraform to spin up like a EC2 and a VPC, and you get this Terraform, you think, oh, that's cool. I'm glad you took the initiative to learn it. But then you have to take that Terraform, turn it to modules, put on the right settings, things like that. So I think it's great that any dev learns Docker, Terraform, Ansible, whatever it is, but it still requires a collaboration to make it professional, fit the organization, fit the current code base.
Yeah, that's a good point. And back to your original description of DevOps too, ML engineers shouldn't think that they're just going to take this and kick it over the fence to a DevOps person and be done with it. And the DevOps person is going to magically make this appear in production. There's going to be changes and conversations going both ways in order to make that happen.
And collaboration is the key to DevOps, working together to achieve a common goal. That's definitely something that's going to highlight over and over in this conversation, the architecture, collaborating with the ops and the DevOps and the devs and everyone working together.
So you mentioned repeatability, and in the land of repeatability, we have this thing called infrastructure as code. You know what? Do we want to just dive into the tooling? I have Jirwat's talking point notes here, and he's got a really good, what looks to be a journey through the history of and what inspires the creation and then use of these tools. So Jirwat, just go ahead and take it away.
So we'll get into the landscape of all these DevOps tools, but I think it's really important to remember what we just talked about. Like, this is a full-time job, right? And we're going to go through all these different types of tools so that you have a lay of the land. You can hear these and be like, oh, that's the configuration management tool, We're not suggesting you go and do a deep dive in any of these. This is so you can talk to your DevOps people, communicate with them better, or just be able to be a little bit more intelligent and ask good questions when these topics come up. So listen to it. Jirwat's an expert in a lot of these areas, and he's got a great overview of these. And then kind of let most of the details fall out of your head and just remember the high level concepts, and you're going to be in really, really good shape.
All right. So we're going to go back a little bit to the old days, and the old days weren't that old, and describe the problem that DevOps is trying to solve or have solved for the most part. So in the old days, people would go into the UI and just go clickety and create servers and create virtual environments or do whatever they need to do. They would do it manually. That is
on AWS console website.
Well, even before AWS, right? You had VMware, You had command lines, right? Even with physical servers, people would go in, log on to the server, and just type in commands manually. So it was almost like a dark secret of how things would be done, how things are configured. And then when that engineer left or that ops left, right, then, no documentation, no idea what that person did. It's hard to manage a professional business that way.
Oh, like
Or even
walking
manage
into a house that was a mess. Just, oh God, what's going on in this server? There's trash all over the floor.
And then, a classic example we see all the time is, okay, one dev or one admin goes into one server, does it one way. Another admin goes into another server, does it another way. Even though they're supposed to be running the same app, different, right? Different servers, different boxes. So the manual part is how ops used to operate. So what DevOps did was take some of the philosophies of dev, right? You have code that you write and you have code that you can review and then ultimately check into a code repository like Git. So that way there's a record of the changes. There's a record of what happened and and other people can run it. So it seems like a pretty basic concept now, but when it was first introduced, it was a game changer. And there was a lot of resistance too, right? Almost like, you're trying to take over my job. So what infrastructure as code does is there's tools like CloudFormation, Terraform, Pulumi that, instead of you going into the AWS console and going clickety to create a server, to create SageMaker, you can write code to do what the clickety did and then review it, check it in. And if you have to make changes, then you could make that change in code, review with your team, say, we're going to change the instance to, M5 large to M5X large, check it in, run it, and you could see the history of what happened.
So you have a code file and it deploys all of the AWS infrastructure for you with 0 clicks. You just run some script and it will spin up all of your EC2, your database, et cetera. Is that what this infrastructure as code does?
Yes. And the other game changer was what I mentioned before. It used to be that different ops would do things differently. Now that you have code, you can rerun this code in another environment, right? By just passing a variable. Let's say you ran this code in dev, you tested it out. There were some bugs with the infrastructure, happens. And then, after a while you got, okay, this works. So we could run that code, pass the variable QA or prod, and the exact same thing will happen. QA and prod, you could ensure what you test in dev is in QA, what you test in QA is in prod. And in the old days, that was not guaranteed at all, right? There may have been like 50 steps you have to run to deploy manually. I guarantee you'll skip like 3 of them or you do 3 of them wrong.
Recently, I deployed a service using Terraform, a server, a database, and everything in a VPC. And the VPC block of code was, let's say, 25 lines of code. It created a bunch of stuff I didn't know I needed to create. So route table, internet gateway, network ACLs, all these things I wouldn't have known to have done myself in order to expose the service to the internet in AWS. It seems like infrastructure as code with their same defaults also helps with simplicity of deploying architecture.
Oh, definitely. That's another great concept from dev that came into ops. Modularity, reusability. You have this module. We put all the complexity behind this box. All you have to do is pass 2 or 3 variables and we'll do the right thing.
All right. You mentioned CloudFormation, Terraform, Pulumi. How do these all compare to each other?
So CloudFormation is AWS specific and Terraform is more generic. You could do multi-cloud, and Terraform is the most popular infrastructure as code tool, is the one that if you're looking for a job, that's the one you should learn. Pulumi comes in. So Terraform is very structured in the way it wants to do things. It says kind of almost my way or the highway. Pulumi takes this concept and adds real code into it. So if you want to do a for loop, an if statement, and be more generic, you can. So it's a trade-off. You could be more dynamic, but it leads to a lot of spaghetti code with Pulumi because it's real code. But if you need that flexibility, it's good. At Dept, we recommend Terraform because it's the most popular and it's the most structured. It's easy to teach. It's easy to not mess up too much.
Also get a lot of online support. It has a very, very vibrant community from what I've found. And I'm fairly new to it, but a lot of support and examples.
And independently, before I even talked to these guys, I came to the same conclusion. I think Terraform's the way to go.
And also, HashiCorp just had a $1.4 billion IPO. So it's a real company. It's not some open source thing that, is unmaintained. So if you do need professional support, you can reach out to HashiCorp or Depth or to say, oh, hey, we have this Terraform. Can you help us?
And one cool thing about Terraform, as Gillette mentioned, is it's multi-cloud support. So if you don't like AWS, which is what we're going to be harping on in this episode, you can use Terraform with GCP and Azure and others. But in the AWS world, there's CloudFormation and now CDK. If we're so AWS heavy, why are we saying Terraform over CDK or CloudFormation,
Right.
for example?
So CDK within the DevOps community is a very intense debate on how to do infrastructure as code. There's one camp that just laid on the table I'm in, where I believe that infrastructure as code should be structured. That you shouldn't do a lot of weird dynamic stuff to it. If you're doing that, you're probably doing something wrong. That's why I tend towards Terraform and CloudFormation is the same way. It's just pass me a bunch of configuration and I'll figure out how to do it. With Pulumi and with CDK, it's taking some of the complaints of that structure and say, well, I want to do this fancy thing, or I want to say, if dev do this, if prod do that. And I want it more like how I code. Both CDK and Pulumi supports Python, supports TypeScript. I think Java's in there too.
Okay, this is a procedural versus declarative code.
Right, exactly.
So Terraform is an HTML file-ish and CDK is a JavaScript file-ish.
Yep, exactly. That's a very great analogy.
Terraform says this is what must be done. CDK says do it this way.
Right.
Okay, so that's infrastructure as code. That's Terraform and friends. I've heard a lot about Ansible. Where does that fall into place?
Yeah. So one of the bad, confusing things about the DevOps tools is this thing. You have infrastructure as code and then configuration management, and they're two different specialties. And the tools that does infrastructure as code well and the tools that does configuration management well is different tools, different companies. So let me describe what configuration management does as a real world example. And we see this pattern a lot. You would use Terraform to create an EC2 server in AWS. And once that generic EC2 server is in the cloud, well, now you got to put your special business sauce into it, right? You got to configure, install security patches. You got to add Unix users. You got to actually install your business app. Well, doing those tasks, Terraform is not very good at it. So there's another tool called Ansible, which does that, where again, through configuration, you can say, okay, install this patch, yum install patch 123, add Unix, add user add XYZ, then run install.sh. So that's what Ansible does. And that's what configuration management does. Once you have a generic server, the configuration management tool installs your business logic to it. So that way it could actually work.
Now, I thought we would do that with Docker.
Right. So a lot of these configuration management tools are getting deprecated because they were designed for the old days where you would actually have either a physical server or a virtual server, right? You would have a Unix server that's a blank slate, and you would have to go in and configure it. So containers are another game changer in DevOps, where it's the old joke. Well, it works on my laptop, right? The dev says it works on my laptop. And the ops says, well, let's just deploy the laptop. One of the great things about containers is that on your laptop, you can do everything on your laptop, right? You could run a Unix server. You could test and deploy and do development on that Docker container. And once you're satisfied, hey, this works on my laptop, you combine it to a Docker image with Unix, the code, everything, and give it to the DevOps team and say, deploy it. It works on my laptop. I tested it. Take this entire thing and go.
The other huge benefit is that they start up almost instantaneously, whereas these other methods can take a long time to start up.
The big game changer is what you do in dev is what you would do in prod. You wouldn't run an EC2 server on your laptop, right? You can't. There's tools that you could kind of mimic it, but Docker and containers are the way to go. It was a major game changer when it was first introduced.
Okay, so we have infrastructure as code that is writing a code file that will create a whole stack on AWS, a whole stack on GCP. In the past, you would log into EC2 instances that you may have deployed with configuration management tools to install the patches and the software. And you mentioned Ansible. What are the other ones?
Sure. There's things Chef, Puppet, Salt. Those are the four main ones. And they all have pretty much equal mind share. The big difference between Ansible and Chef and Puppet is that Ansible is push. You run a command from a server and you push out the configuration. With Chef and Puppet, you have an agent on the server and it pulls the configuration. I prefer the push model just to show my bias because I like that control, but they all pretty much do the same thing.
And now these configuration management tools are slowly being phased out in favor instead of Docker containers. You can deploy Docker containers through Terraform to like ECS, right? Fargate. And then there's an alternative, Kubernetes. So we have Docker containers now. So talk to us about ECS, Fargate, Kubernetes. When you use one, when you use the other, what is Kubernetes? How much can you do everything with Terraform, et cetera?
Yep. So you made a very great point, right? Things like Ansible, Chef are being superseded by a Docker file. So the patches you would do in Ansible and Chef and installing your apps that you do in Ansible and Chef, now you would just do in a Docker file. And the good thing about a Docker file, again, you could check it in. It's a real file that you could pass around. So Kubernetes, so once you have a container on your laptop and you give it to DevOps and say, deploy this, that's where the real fun begins. And we can provide a link to this infamous cartoon or a diagram where how do you deploy a container to AWS? And there's literally 15 ways to do it, which leads to a lot of confusion. And even among DevOps professionals, there's a lot of confusion about how to best deploy a Docker container. And everyone has their own personal favorites. At Dept, we recommend ECS, Elastic Compute. I forgot the acronym.
Elastic Container Service.
That's what we recommend in the professional environment because out of all the options is the easiest. It has good dev support and prod support, but that's if you have a good DevOps team. If you're just like a one-man show, things like App Runner, that's good. That's simple. There is Elastic Beanstalk. That's nice and simple. It depends on what you're trying to do. And then the big granddaddy of them all is Kubernetes. And that has a lot of hype around it. The main thing I want to stress about Kubernetes is it's a very complex ecosystem to deploy a container. And people have careers just dedicated to Kubernetes alone without any other skill set. And they make great money because it's a very complex to get right. And what Kubernetes does is it takes a container and adds all the production values to it, right? Clustering. You can employ multiple containers of multiple copies of the container. That way you could manage load, right? If there's 100 users, you could have 2 containers. If you have 1,000 users, you could have 3 containers, 4 containers. There's a lot of security around Kubernetes to have it safely talk to other containers or to other external services. And that's just scratching the surface of what Kubernetes provides for you.
I almost get the impression it competes with AWS. It's its own entire server farm orchestration service.
Yep. So all the major clouds have their own implementation of Kubernetes. In AWS, it's called EKS, Elastic Kubernetes Service. On GCP, Kubernetes was developed by Google. So in Google Cloud, it's Kubernetes engine. Azure has their own implementation of Kubernetes. And the good thing about these called managed services where you can build Kubernetes on your own from scratch, right? And there's this famous blog called Kubernetes the Hard Way that will give you step-by-step on how to, if you want to build it by hand. But what AWS, all the cloud providers does is, okay, well, if you want Kubernetes, run this Terraform, click this button, and we'll create a Kubernetes cluster for you that works with all the AWS services. So it's not so much competition. It's just another way of deploying containers into the cloud. And it's probably the most complex way.
The most complex. Why would we want to use it ever if it's the most complex?
So especially in a production load, like if you have a lot of intense production requirements, like you have a lot of teams and these teams do a lot of microservices. So let's say you have 18 containers, 18 different images you have to maintain. Kubernetes is great for that. automatically scaling up and down the load, it's great for that. And to be honest, there's a lot of hype around it, right? So tech people love hype, the new shiny, right? Oh, it's a new toy. I like to play with this new toy. That's a huge driver in a lot of architects. Here at Dept, we subscribe to keep it simple. The simpler, the better. The simpler it is, it's easier to maintain, easier to manage, easier to teach other people. So Kubernetes is the opposite of simple.
Mhm.
I mentioned the pay, right? So a Kubernetes engineer can command a pretty high salary. So I've seen this so many times. Well, I have an opportunity to use Kubernetes at work. I'm going to do it because I want that skill set.
The other benefit, like just full disclosure, I'm by no means a Kubernetes expert by any stretch. When I think of this from an architectural perspective, I do think about staffing. And I think that what we're expressing here is actually a little bit of a hot take in the DevOps community. I think there's probably going to be a certain portion of people who are like, whoa, what do you mean not Kubernetes? What do you mean start with ECS? And I can get that, because one of the advantages of using Kubernetes is even though those people do command a premium, that skill set is quite available. It's also open source. So, the YAML files that you specify for Kubernetes, they're open source. They'll work largely, and Jirawat might be able to correct me on this, largely work between different managed service providers for Kubernetes, those are nice benefits too. But I completely agree with what Jirawat is saying is unless you have a team that's ready to do that and ready to deal with the complexities of managing Kubernetes services, it's much better to start simple.
And I'll talk about my own personal journey with Kubernetes. At my previous job, Kubernetes was already there, right? So gave me a good opportunity to learn it. And I made so many mistakes, production level mistakes, things like, permanent volumes, security, networking. It's such a complex topic that it's not just like, you think, oh, okay, well, I did this tutorial. It works. Cool. You actually deploy it in production with real users, real load. You'll learn soon enough that things can go drastically wrong. And if you don't know what you're doing, it's hard to debug. And I'll actually send you a infamous flow chart of if things go wrong in Kubernetes, here's all literally 20 commands you have to run to figure out what's going on.
So you said Kubernetes is overly complex. And now I realize you're not just saying that to use Kubernetes is over complex. You're also saying the complexity of the environment you might be trying to orchestrate corresponds with the complexity of Kubernetes in use. So if you're a startup, let's say 100 employees, you probably get by using all of AWS's services. If your project is wildly complex, then you're going to want the tool to task, which is going to be probably Kubernetes.
And definitely before you go to Kubernetes, make sure that it's a informed decision and make sure that you talk to people who've done that, both pro and con, right? You'll have people who are passionate about Kubernetes in production. So talk to them too and get their viewpoint on this. But it's a huge investment, hard to hire, expensive to hire. So it's almost like a Lamborghini, right? We all love Lamborghinis, but it's hard to drive, easy to crash. And there's a lot of quirks. Like if you Google how to back up a Lamborghini, you can't use the rear view mirror. You actually have to open your door and physically look behind you. So we all love Lamborghinis, but make sure, you know how to use it.
I think another thing about Kubernetes, I always like to remember that Kubernetes was created to help run Google's infrastructure of containers. Google, right? Like it's inherent.
It works.
Very complicated. Like it's going to be really good, but it's going to be really complicated and it's meant for Google scale problems. Maybe if you're successful, oh my God, my hat's off to you and you need that sort of complexity. Amazing. And you're just starting out. I don't know. I don't know if I necessarily agree with it.
If you start simple, you're not locked in, right? Your logic is in that container. So if you started with ECS, and ECS is going to carry you pretty far to Matt's point, if you ever get to the situation where, wow, we have Google scale load, one, hats off to you. You've a success. You could definitely migrate to Kubernetes.
All right. What is ECS? Okay. I'm going to read this flow chart. This may be weird in audio format. I'm going to drop, of course, all of the images that Jirawat's talking about in the show notes for everybody to look it up afterwards. But I'm going to read this flow chart and see how it goes. It says, which AWS container service should I use? Where do you want to run this container? On-premise? Then Kubernetes? Yes. EKS? No. ECS? And then OpenShift, which I've never heard of. Rosa? And then it says, where do you want to run this container? In the cloud? What will this container do? Run build jobs, code build. Run batch jobs, batch. Run apps serverlessly. For real though? Yes, Lambda. No, Fargate. Serverlessly, no. Who will manage this? Kubernetes will be EKS. AWS manages it. I'm going to skip that section. I'm going to manage it. You're going to be doing it a lot. If you know, then Lightsail. If yes, then EC2. And then it says, if you want sort of both container on premises or in the cloud, it says Greengrass. I would have actually thought we were going to say like a mix of Kubernetes and ECS. But we have a lot of container services that can be used here. We have EKS, ECS, Lambda, Fargate, Beanstalk, App Runner, Lightsail, EC2, Code Build, and Batch. Girowatt, save us.
Well, so even among people who are doing this day in and day out, picking the right way to deploy containers, it's a complex issue on itself. That's why if you're just doing machine learning and you want to concentrate on that and not worry about this complexity, App Runner is a great way, right? You just, hey, here's my container, and AWS does everything for you. Create the load balancer, create the network. All you have to do is just provide container. App Runner is a very good thing.
My first time hearing of App Runner. God damn it.
It was just introduced about a year ago, just before the pandemic, I think, or maybe right after the pandemic. So again, that's the other thing about DevOps. Okay, what you knew 5 years ago may not be relevant, and it's not relevant today, right? App Runner is it's their latest toy to deploy containers, and they put all their knowledge of what went right and wrong with other products into App Runner.
And then you were going to mention Elastic Beanstalk.
Elastic Beanstalk is probably one of the oldest ways to deploy a container, and it does a lot for you too. So it's a little bit more mature, a little bit more battle tested. Requires a couple more clicks, right? But in the grand scheme of things, still very simple. That clickety guides you through of what you want to do. It says, oh, hey, do you want, Python, or do you want Java? Do you want machine learning, or do you want to do, web apps? So it's almost like a questionnaire that you could just click on and say, okay, got my stuff.
So coming into this discussion, I thought it's really boils down to EKS, Kubernetes, or ECS. But then we also have Lambda and Fargate.
So that's a whole other topic. There's this thing called serverless. And I'm going to put you can't see in the podcast, but I'm going to air quote serverless. There's, servers still behind the scenes, but basically you don't have to manage the servers. With Lambda, you just say, well, here's my code. And it could either be code that you upload, or it could actually be a Docker container. And Lambda will say, okay, I'm going to just charge you for actual usage. Like if 5 people hit your Lambda, then I'm just going to charge you for those 5 users. So it's a bit of a cost savings. But Lambda is a very complex topic, and Lambda and serverless is a complex topic. So I wouldn't recommend that for a beginner, more for cost savings than anything else.
Got it.
And I want to stress that even among people who've been doing this for a long time, I've seen so many bad implementations of Lambdas, seen so many bad implementations of ECS, tons of bad implementations of Kubernetes, right? It's like, oh, well, that's not right. It's so complex. And then to toss it back on me, I'm sure if you looked at my implementation of Kubernetes from a year ago, you say, that's bad. What you're doing there.
One take, correct me if I'm wrong in any of this. The one way I've thought about Kubernetes versus hosted services, managed services in the cloud, like AWS, Azure, and GCP. I've seen them as almost 2 different approaches. I've always thought of Kubernetes as a very general approach, almost the way Terraform is general cross-cloud infrastructure as code. I thought of Kubernetes as a way to take your Docker files, and no matter where you're running it, and it can be on-premise too, in your company's data center, it'll run the same no matter where, GCP, AWS, and Azure, or on-premise. And it's going to be using open source tooling instead of the cloud provider's service for that equivalent. So if you're going to use Kubernetes, you'll be using a Postgres Docker container, as opposed to if you're going to use AWS, you'll be using RDS, their hosted database service. So with Kubernetes, you have at your fingertips all of the world of open source tooling. You know how those things work. You're not locked in. In cloud land, using, let's say, Terraform on AWS, you're using their services. RDS is their implementation of relational databases. It's not open source. You don't know how their Postgres stuff happens. In Kubernetes, it'll have its own secrets manager. AWS has its own secrets manager. There are pros and cons. In the case of AWS, by using their services, you get all the patches, the updates, everything's black box. So it's more managed and secure. By using Kubernetes, you have more visibility, more control. Everything's open source and you can deploy it anywhere. Is that all right so far?
So you touched on some very good selling points of Kubernetes, right? It's supposed to be generic. So there's this command called kubectl, kubectl. Different people pronounce it differently. Kubectl, kubectl. But with that command and a YAML file, you can deploy your app, whether it's posted on AWS or GCP or Azure. At least that's the promise. In reality, what gets you is that security model, right? So if you deploy Kubernetes in AWS in a production level environment, you're going to have to tie into the IAM of AWS.
So you'll still be using these services, even with Kubernetes, if you're deployed in the cloud.
Right. You just can't help it, right? Especially the security model. It's pervasive among all the services. And again, so let's say you take your Kubernetes cluster and your app, and you try to deploy it onto the GCP Kubernetes engine. I almost guarantee you, any serious code that you have to access resources, you're going to have to hit that security model. And even if you don't, right? So let's use a perfect example, a real world app. It's going to write like in AWS, right? You'll probably write to an S3 file or S3 bucket. If you deploy this on, GCP, you're probably going to have to write it to the GCP equivalent of the S3 bucket. So yes, Kubernetes promises making it generic and common, but in practice, it's not. And then that kind of leads to this other hot take of DevOps multi-cloud, right? You'll hear this a lot where, our application or our product, you can deploy it on AWS or GCP or Azure. It's easy. It's not easy. That's a sales pitch. Anyone who tells you it's easy is trying to sell you something.
That's the idea of deploying a Kubernetes cluster on different cloud providers. How about Terraform with the way it orchestrates different cloud providers?
Right. So the good thing about Terraform is that it's just a configuration language, right? So the good thing is the skill set that you learn to code Terraform on AWS is transferable to GCP. One of the links we're going to show is cloudcompare.in or compare cloud. It'll be in the link, but it compares, okay, if you do this in AWS, here's what you have to do in GCP, right? Equivalent services.
So Terraform is not trying to accomplish universality. It's just trying to accomplish universal accessibility.
Right.
To the different services.
Right. And it's a common language, right? So if you know how to do Terraform in AWS, let's say a perfect example, here's a Terraform to create an S3 bucket in AWS. Now, if I have to create the equivalent in GCP, you say, okay, well, in GCP, here's the equivalent object storage, same style of Terraform code, just the GCP flavor.
All right. So speaking of multi-cloud, tell us about Azure and GCP.
Yep. If you're going to learn one, AWS, 90% of the companies are going to use that. If you interview for jobs, right, you're probably going to hit AWS. Azure is the second most popular one in the business world because Microsoft doesn't want to beat AWS. It wants to beat Google. So if a C-suite can negotiate well, you almost get Azure for free, right? They'll just kind of give you the farm just to get you on the platform. The other one is that the joke is if Microsoft acquires your company and you're on AWS, you won't be on AWS. You're going to be on Azure. They're going to force you to go on there. So I have some friends who are got acquired by Microsoft, and that's their big project. GCP, it's great from a UI level. GCP probably has the best UI of the three. The bad thing about GCP and Google in general is Google loves to kill products, and you're not guaranteed backwards compatibility in GCP. Like AWS will bend over backwards to accommodate things you've done, 10, 15 years ago, right? That's why you still have ECS Classic. You still have, the way you configured S3 buckets 18 years ago or whenever S3 came out, you can still do it today for the most part. Google hates backwards compatibility. That's why it's the least favorite among the three.
Have you seen that then? Have you seen services go non-backwards compatible or entirely defunct?
Yep. There's actually a great list of GCP things, and we could find the link and post it. But there's a great list of, hey, this is the things Google breaks, right? These are the things Google like to kill. From a UI perspective, it's excellent. It's like the best UI I've used. AWS is very clunky UI wise.
The real conversation for our listeners is going to be around the machine learning services offered by the two providers. And I think we should talk about Kubernetes machine learning services. I personally use SageMaker on AWS. I've talked about it in the last few episodes, but just to brush up, it's a suite of machine learning tools. It's not one machine learning tool on AWS. It offers training a model, including parallelization, distributed training, monitoring the model training process. When you're done deploying it to an endpoint, that endpoint can be a REST endpoint, one that you call as a batch endpoint. So if you're just going to do one-off inferences on large amounts of data so that you're not charged for the running REST endpoint, or recently serverless model calls, which is absolutely amazing. And then a whole bunch of monitoring tools on top of your model. So as new data comes in from new users, does that new data distribution over time drift away from the type of data you trained on? And then it will email you if so, which is really powerful. And is there a bias? It does all this stuff for you. And I'm completely unfamiliar with GCP or Azure's machine learning offerings in that domain. Are you familiar with them at all?
Nope. So I think that's where the collaboration comes in. That like even on AWS, everything you describe is new to me.
I see.
And this is, to 2 points of this podcast is one, you can't know everything, right?
You can't.
It's such a complex field. And especially, if you're trying to learn both DevOps and machine learning, that's a big apple to bite, right? You almost want to pick one or the other. The other thing is collaboration where, oh, wow, look, SageMaker can do all these things. And, if you go to a DevOps team and you explain that, right, it's probably going to be new for 99.9% of them. So it requires a collaboration of, oh, hey, here's all the stuff you can do in SageMaker. Let me show it to you, what I did in Dev. And then the DevOps team can take a look at this and say, okay, well, we need to secure this. We need to do this with the container, install patches, things like that. Change your Docker file to install this agent, patch, whatnot. So it's a collaboration and a learning experience for both sides. But yeah, from a machine learning perspective, I'm very ignorant. And I'm hoping to get better by listening to your podcast.
Hey,
Back to the archives and learning about it.
Go through, you might like the last 2 episodes on SageMaker. Everything prior to that is sort of machine learning basics. There's not a lot of cloud anything until the very end there. And I do want to mention Kubernetes. A future episode, I'll talk about the competitive open source machine learning pipelining tooling, because I just mentioned SageMaker. It has a whole suite of pipelining tooling, but it's all hosted in the cloud by AWS for you. Kubernetes has its own. It's called Kubeflow. And it can orchestrate a pipeline of machine learning tooling for you that includes the data engineering, the data ingestion, engineering, transformation, and then various forks in the road like analytics and stuff like this. So if you enjoy SageMaker and you want to do it open source or run anywhere, you might look into Kubernetes Kubeflow. There's other projects out there like Apache Airflow and some others.
Oh, the one thing I do want to mention, because it comes up a lot, is cost. And that's, if you're deployed to a production, definitely your CIO and your CTO and your CFO is going to say, hey, what's this expense? But it's really dangerous when you deploy to your personal account. And I've got hit with this a lot. That, oh, okay, Kubernetes, this is cool. I deploy it to my personal account, leave it on for like a day or two because I forget to tear it down. Next thing you know, you get a bill for, $80, $100, and that can be a surprise. So the one thing I definitely recommend is if you're trying to play with this on your personal account, every cloud provider has a bill monitor that says, oh, you've spent more than $20. I'm going to email you. You spent more than $80, almost like a credit card, right? I'm going to email you and inform you. So definitely before you do anything, turn that on, or else, you may get a surprise at the end of the month.
So we talked about a lot of tooling thus far. a lot of the history of DevOps. And we alluded to that DevOps might not want to be a role that you take on as a machine learning engineer, that it would be too big a pill to swallow. Stick to your guns in the machine learning space, learn the SageMaker tooling through and through. So for my listeners, the machine learning engineers, let's say they create an AWS account, they spin up a SageMaker project, they open SageMaker Studio, Jupyter Notebook, they start typing away, training a Keras model. They really learn SageMaker nuts and bolts. And maybe they can even deploy a SageMaker model now as a REST endpoint using model.deploy. Now that machine learning engineer may be a one-man band, but they still want to get this model out into the wild. Maybe they want a web front end, a UI, a React front end on an S3 bucket with CloudFront distribution in a Route 53 URL. And that front end's going to have to communicate with some backend, let's say a Fargate Python FastAPI server that then kicks off the machine learning model inference endpoint. So everything I just said is I would consider totally doable by my listeners. Maybe they would orchestrate that entire stack I just mentioned using Terraform. So where does that wall start effectively? What would be a good suite of named tools in AWS, presumably using Terraform, that my listeners could get started with to actually deploy a product? And then where does that wall begin where now you actually want to really consider having a DevOps professional helping out with the rest of this process?
Yeah, that's a great question. So I don't want to dissuade anyone from learning Terraform or Docker, Ansible, or Kubernetes. I just want to highlight that some of these tools may have a steeper learning curve than others. And actually, that's how I learned it too, right? So I started my career as a Java dev, and I thought, oh, well, Ansible looks pretty cool. I want to play with that. Terraform looks cool. I want to play with that. And eventually, it became my career. So I don't want to dissuade anyone from learning it. For me, the demarcation point is security. How valuable is your data, or how secure is your data if your data got hacked, leaked into the wild? Is it okay? Oh, it's just, public data. It's no big deal. Or is it, sensitive PII data, medical data, consumer data, identifiable data? If the answer is, if this data got leaked, it's bad time for me and my company, then that's when you want to hire a professional to take a look and make sure that the proper security precautions are met.
Yeah. And I'll just add on top of that, like, if you're going to play around with a development instance with some fake data, that's great. You should do that. And if you're going to release it to some friends or friendly people, you should do that. We're not trying to scare you, but like Jerwood said, you have anything identifiable there, you definitely want somebody's eyes on it from a security perspective. There's a lot of very easy mistakes that you could make. And you've seen this in the news where different corporations have leaks. You don't want to be one of them. Even the people that are really, really good at this stuff, things slip through the cracks. And it's just prudent even for the best people to have a professional set of eyes, look at the security of things. The other thing that just to consider is, like, if you're just using bare EC2 instances, you want to make sure those things are locked down and people can't just go and use them for something like crypto mining. I know it's a little bit paranoid, but that's a real thing. If you leak your keys or, open a port that you shouldn't, people can hijack that machine and run up your bill pretty intensely. So you got to watch out for that type of stuff too. That's a more exception, shouldn't scare you. It's just things to be aware of.
And a lot of these DevOps tools with the infrastructure as code and the configuration management, checking it into a repository, it's about working with other people, working with other teams. If you're a one-person show, then you're a one-person show. You don't have to document, you don't have to communicate. So experiment, try it, learn it. We don't want to say, you can't do this, right? You can't do this. Just be aware of the complexity up front. But like me, you may learn it and well, I like this more than Java development. So I'm going to change my career a bit. Your career's a journey.
All right. So security, that's the demarcator, or even like complexity. If you're in over your head, and you'll know it when you see it. But as far as tinkering and deploying your project, as long as you're not dealing with secure data, PII, what does that stand for? Personally identifiable
information. Yep.
Okay. So if you're dealing with PII, if you're dealing with security, get a professional. Get these guys, Matt and Jirwat, hire Dept. And if you're just tinkering around, and you just wanted to have some fun, you built your machine learning model on SageMaker, you deployed it as a REST endpoint. Matt, can you guide us through an architecture? Can you talk us through like what services then our machine learning engineer would want to use on AWS to expose this model to the internet?
Yeah. So you already said it's SageMaker. I mean, if you asked me to come up with like a beer napkin template of something, I'd say throw your static site on S3 fronted by CloudFront, put your, I think you mentioned maybe it's a Python service, put that in a Docker container running on ECS, hook it up to a relational database service. I'm going to presume you need to have some kind of state stored there. We always use Postgres. We really love Postgres. And then, terraform that guy up. I'm curious if Jira would change any of that though.
Yeah, those are all great recommendations. My advice is, especially if it's not secure or sensitive data, experiment. That's how we all learn, right? Try it out, see what happens. And one of the good things about AWS is that there's a lot of documentation, sometimes too much, but pick one, try it out and see. But the advice Matt gave is excellent and spot on. And
one more thing to add that we totally forgot is that you should really put a automated build and deploy pipeline in place too. So using something like Code Pipeline or, Circle CI or something like that, choose your flavor. That is something that will pay off in spades. It's not 100% necessary, but you'll find that it's going to help you quite a bit. Take your code from source control, push it automatically out to your infrastructure. It's extra work though.
Talk a little bit about that. So this is just CI/CD.
Yeah.
Yes.
Continuous integration, continuous deployment. Yep.
Speed run the process. Like what do they git commit?
Generally, I mean, there's a million different flavors of it, but in general, it will either watch or periodically build, or you can manually trigger from your source code repository. It will assemble your code, run tests, run security scans, whatever you need done to assemble your code, package it up into what's usually generically referred to as an artifact, which is package of files, basically. That's the, usually the continuous integration piece. And then the continuous deployment piece is taking that package and pushing it out to your infrastructure and turning it on and releasing it to users. So it's really important to do that to make sure that that process is repeatable, that it's not prone to human error. And it also just saves you time. I've seen a lot of projects in the past that skimp on that step in the beginning, and you just end up paying for it as you go along. So it's usually kind of like my number one piece of advice is don't skimp on your CI/CD when you start up. It is a bigger investment. It's not something you want to learn along with everything else, but it is something as you think about deploying a piece of code out to the wild, if you're going to do it a bunch and this is going to become a real thing, that's definitely something that you want to invest in that.
Yep. And it's probably something that's from a selfish perspective, you want to do too, right? This is how actually I learned automation, do some Java code. Hey, it works locally. Now I want to deploy it to dev so that, the QA folks and other devs can take a look at it. I do it manually once. Oh, great. I do it manually twice. Okay. After 10 times, well, I'm not being paid by the hour here. So let me just automate this so I could just, check it in. And then a machine behind the scenes does it for me and I can go get some coffee.
Awesome. Thanks, guys. All right. Well, Ship It IO podcast, another of Dept's podcast network, link in the show notes, likes to do picks at the end of their episodes. And I like that. And a pick, Matt, what is a pick?
Pick is just, it could be anything that you are currently into, that you're digging lately. It doesn't have to be technology related. I tend to pick things that aren't technology related. I don't know. So I can go first if you want. All right. My pick is the show Succession on HBO Max or HBO. I'm late to the game on this. Some people are probably going to laugh at me, but that show is fantastic. Jeremy Strong, the guy that plays Kendall Roy on that show, is amazing. So I will pass to Tyler.
All right. Mine will be apropos of this episode, actually. I created a Terraform script that spins up a cloud game streaming service, DIY cloud gaming, If you go to my GitHub /Lefnir, LEFNIRE /DIY-cloud-gaming, little Terraform script. Or you can just Google Quest to AWS. They wrote a blog post on how this whole thing works. And what you do is you spin up a Windows 19 server on AWS that has NVIDIA graphics card drivers installed, ready for VR gaming. You install virtual desktop on the server, and you connect to that virtual desktop instance using Oculus Quest 2's virtual desktop app. And now you can do AAA VR gaming without a PC. So you can play Half-Life Alyx, Asgard's Wrath, Lone Echo, all the really impressive VR titles that can only be played with a gaming PC can now be played without a gaming PC. I'm keeping my eye on NVIDIA with their GeForce Now service. It looks like they've got their eye on Cloud VR. They're calling it Cloud XR. They have a server and client app that are actually in the works. So keep an eye on them, but you can actually start gaming without a PC and without any of these other services, all DIY. Maybe you first get your hands dirty with Terraform. All right, Jirwat.
Well, mine's going to be a little boring, but there's this language called Go. And actually, that's what Terraform is behind the scenes written in. And it's a very C-like language. So I mentioned in the podcast, hey, I used to be a Java developer. Then I did some Terraform and Ansible, and looks pretty cool. And I pivoted my career towards that. After doing DevOps for a while, I was like, I kind of miss programming, like real programming. So learning Go, which is a new programming language, is my current thing. And it kind of ties into DevOps because a lot of DevOps tools, especially from HashiCorp, it's written in Go. So if I have to hack into Terraform, I can do that.
That's a fun language. There's something very freeing about actually creating a native executable and not needing anything else to run it.
Isn't Docker or Docker Compose Go based under the hood?
So Docker Compose is interesting because Docker Compose used to be written in Python. And then I think they converted, like the latest version of Docker Compose is Go based now. I believe you're correct. It was from Python to Go. And and the cool thing is that now the reason Docker Compose used to not work very well with Docker itself is because it was written in two different languages, couldn't share libraries and things like that. Now it can.
I have a simple, when friends ask if they want to get into dev, where should they start? And I say, what kind of dev? You want to do web or apps? JavaScript. You want to do data stuff? Python. You want to do server stuff? Go. That's my quick. Did I ruffle any feathers? Any alternative statement?
I just would have said Python and JavaScript. Just Python and JavaScript, like Python for your backend and then JavaScript. You'll never go wrong with JavaScript. You didn't ruffle my feathers though. It's just my answer.
So it's funny because I had this exact same, my son is in college and he's about to graduate. So he's trying to enter the job market, right? And he has a computer science degree and they taught him C++ as the main language, right? It's a very traditional computer science education. And I told him, well, with C++, your job market's a little limited. So I actually took him to Python because Python, you could use it from like a real developer language. You could also, if you want to go into DevOps, you can, Python is a very good system language too. So I recommended Python to him. So I was teaching him, talking about learning, right? I said, well, actually, if you want a job, let me just teach you Terraform and AWS. I could teach you enough that you can pass an intro level interview and, hopefully get.
And fake it till you make it, buddy.
Oh, anybody who wants to learn this stuff, A Cloud Guru.
Oh, yeah.
So they have lessons on cloud. So Azure, GCP, and AWS. And their lessons are pretty formal and dialed in because they're intended for you to pass specific certification tests.
First of them, not all of them.
Right.
Yep.
They have like a learning track where they're like these really dialed professional video courses. And so I'll post a link to their learning track flowchart, one of which takes you down the path of data science and machine learning, specifically by way of AWS. Obviously, a lot of SageMaker stuff, but the whole path is like really professionally done, and it's how I've learned. It's entirely how I've learned AWS.
In a second, a cloud guru, because my son is going through a similar path of learning. Initially, I was trying to teach him, but that didn't turn out to the greatest. So then he went to YouTube. He went to official AWS videos, O'Reilly Learning. Eventually, the cloud guru is the one he liked the best.
That's how I
guided him
learned
in the right
AWS.
direction.